Hi everyone, this video is going to be all about J.J. Thomson and his model of the atom. J.J. Thomson chronologically came just after John Dalton, and he decided to push Dalton's ideas about the atom forward using some experimental evidence. So his big claim about the atom is that atoms contain small, negatively charged what he's going to call subatomic particles. Sub meaning below, atomic, the atom. So something smaller than the atom, some kind of particle smaller than the atom. And we're going to henceforth call these particles electrons. He didn't come up with the name electrons. He actually said corpuscles, but that's a pretty gross sounding word, so we'll stick with electrons. So his main idea is that atoms contain small, negatively charged subatomic particles called electrons. And he used an experiment to come up with this idea. And when he interpreted his evidence, he decided we must have these small electrons present in atoms, not just a big indivisible sphere. So what he did was he set up an experiment using a cathode ray tube, a CRT. You might have heard of it from a CRT TV. One running power through this particular vacuum tube, he saw that a beam of what appeared to be light would shoot from this negatively charged plate towards a positively charged plate and would extend forward through the tube. But he had a feeling that it wasn't light and wanted to test that hypothesis by applying charge and magnetic force to this beam that was generated as soon as the power supply was turned on. So when this beam was exposed to a positively charged plate and a negatively charged plate, what he found was that the beam actually altered directions. It bent towards the positive charge. What that told him is whatever this beam is made of, it must be attracted to positive charge. So that means this thing itself must have a negative charge. And since everything is made of atoms, that must mean there's this part in the atom that has a negative charge. So we're actually going to start breaking down that indivisible sphere into smaller pieces, subatomic particles. So he didn't quite know how to piece together all this evidence, and the best model that he could propose was taking John Dalton's indivisible sphere and embedding inside of it these small, negatively charged subatomic particles that he called electrons. Now, he also knew that you can't all of a sudden just say that atoms are negatively charged, because before we'd assume them to be neutral, and we know that they act neutral when they're not split apart into these smaller pieces. So he hypothesized that maybe this sphere that surrounded these negatively charged particles was positively charged itself. So we still have this sphere, but it's now positively charged because there are these negatively charged electrons embedded within it. So his model kind of had two components: the electrons and this positive sphere. So that all in all, we had a neutral atom. And this model didn't necessarily push forward our understanding of how atoms link to form compounds, but what it really did do for us was say that particle diagrams don't show everything. And it introduced to us this concept of subatomic particles, which is really where our developments are going to come from in the years to come as we think more and more about the model of the atom. So these were J.J. Thomson's contributions. I recommend being familiar with the cathode ray tube experiment and also with his model of the atom, thinking about how it's different from Dalton and how we might start making improvements to this model based on future evidence.